All right. Hello, everybody. Super excited to have you guys join this month's Learn and Lead session. We have an exciting session planned for you today. Just some usual housekeeping rules. We will have our speaker who's going to be doing the talk. I will hand it over to Padmini, who's going to introduce our wonderful speaker. So while the speaker is giving her presentation, please keep yourself on mute. If you have any questions, comments, feel free to drop them in the chat and definitely save them towards the end because there will be a Q&A after the talk is done. And with that, I'm going to hand it over to Padmini. Ujjwala, super excited for your talk. Over to you, Padmini.
Thanks, Uvika. So, hey everyone, thank you for being here. We have amazing Ujjwala. Ujjwala Kashkari is the co-founder and chief strategy officer at Artelligent, where she's on a mission to make robots an essential part of business operations across the US. From Artelligent's innovation lab in Mumbai, her team combines off the shelf robot platforms, 3D printing, and conversational AI to rapidly prototype and deploy custom robotic solutions for companies like Coca Cola, DHL, and Reliance. As an authorized reseller of service robots and cobots in the US, Artelligent bridges India's deep engineering talent with American market demand, serving hospitality, healthcare, and retail clients across APAC, the Middle East, and the United States. With that, welcome, Ujjwala. So excited to hear you today.
Well, that was a great introduction. Thank you so much, Padmini and Yuvika. And, I want to say before I get started, I love the community that you've built. I've obviously attended a few sessions before, and I've had the opportunity of seeing you both in DC for the India AI Pre-Summit. And just love everything you're doing. With that, very excited to talk about robotics. Of course, robots are having such a cultural moment today, but let me go ahead and share my screen. And I have a presentation for you today, and it's asking me to enter a password. Whoops.
You can share.
Yeah, I should be able to. Oh,
You just have to hit the green button at where it says share screen. You have the ability. Perfect. I think something is coming up.
all right. Do you see my
Amazing. Oh,
presentation?
yes, you see it. Yep.
All right. I can't hear you as well, but hopefully that'll get fixed. So, very excited to talk about robotics today. As I mentioned earlier, robotics is having such a cultural moment. It's very likely that you've seen a robot doing a somersault or a backflip at a conference. There's just um, robots everywhere in your favorite series, and who can forget Jensen Huang with at NVIDIA GTC with all the different humanoids talking about how robotics is having its ChatGPT moment. So my hope today is to translate what exactly does it mean for robotics to have its ChatGPT moment, and why are we at the inflection point within robotics. So to better understand where robots are today, let's take a journey back in time and see how it all started. So robots aren't really new. They've been around for over 6 decades now. And in 1961, it was General Motors that developed the first industrial robot arm. In the same decade, you have Stanford that came up with the first electric computer-controlled arm that became sort of the origin for software controlling hardware. And then for about 3 decades, you have robots mainly stayed in the industrial use case, and also certain research labs like Honda Research Lab was working on a walking humanoid called ASIMO, which is an acronym for Advanced Step in Mobility. And outside of Honda, there was also SoftBank that acquired a French company. And there was I don't know if all of you remember, Matthew, you probably remember Pepper and Now were very popular early humanoids. but you would see them at showrooms and retail as concierge robots. Now, in 2003, you had three co-founders working together to solve a very interesting problem, which is if you took a warehouse space in 2003, a lot of time was spent moving packages from one space to another. And in many cases, you had either a conveyor system or you had a forklift with a human being. So they started working towards developing these mobile robots with barcodes on stickers, and these robots would follow those stickers in a warehouse space. These robots could also pick up an entire shelf with packages, as you see in the image. And in 2012, Amazon acquired it, Kiva Systems, for $775 million. At the time, it was the largest acquisition in robotics. So to give you a little idea about positioning, when Kiva Systems was acquired by Amazon, they had clients like Walgreens and Gap, but Amazon, of course, retains a lot of these robots for themselves. And in some ways, I would say this acquisition changed the game of e-commerce and fulfillment. It enabled them to now use the same warehouse and store more goods, which means the costs were brought down. And it really helped them position themselves and change the game entirely. Now, Boston Dynamics, you may have heard of Boston Dynamics, was a huge research lab, an offshoot of MIT. A lot of the funding that they received, which is maybe around like $200 million, was from the US government and DARPA to build a quadruped or a robot dog for carrying military gear. So there's a lot of amazing research that's going on. They were actually on an engineering level able to deliver what they had set out to do for DARPA. But the big dog, which was introduced in 2015, and then I think 2 years later was featured in Black Mirror, and sort of has this reputation. I would say even today, people are pretty intimidated by the robot dog. While the robot worked, it was so noisy that you could really hear it from a mile away. So it didn't really work out for DARPA. And Google decided to acquire Boston Dynamics. And their agenda was to turn it into a profitable company in 3 to 5 years. So that did not happen. They ended up selling it to SoftBank. And SoftBank they did some development. They actually converted Spot into a sleeker, more industry-ready robot dog. However, they could also not make Boston Dynamics a commercially viable company, and they eventually sold it off to Hyundai for, I believe they sold 80% of the company to Hyundai. So Hyundai and Boston Dynamics partnership has been very successful. And that's because they owned a lot of the supply chain that is required to build a robot dog or a humanoid. So when you take the automotive industry, a lot of the motors and the actuators and all the parts are fairly similar. And that's one of the reasons why Hyundai has been so successful. So today there are two robots. They also had Fetch, and I'm not entirely sure what happened with Fetch, but Spot and Atlas are two robots, which is a quadruped or a robot dog, and they're humanoid, which is more a robot that has human form that is currently used in manufacturing. And we'll talk a little more about Atlas, but I think it's a really interesting story of how they started off as a lab, received funding from the US government, and then went on to and still working on being a commercially viable company. And in 2025, Google surpassed 1 million. They have 1 million robots deployed around the world. And to give you an idea of the scope, there are 4 million industrial robots deployed around the world. So quite the scale, I would say. And they also surpassed Walmart as the largest retailer in the world. So why is everyone talking about robots today? I would say there's been a huge psychological shift, especially when you have key figures like Sam Altman talking about how AGI would be wasted if it's not really out in the physical world. Or as I mentioned earlier, you have someone like Jensen Huang getting up on the stage, introducing all these different humanoids, and then earlier this year talking about, can you all hear
About the same size.
by the way?
Yeah, we
Okay.
can hear it. Yeah.
Great. So what exactly happens when you have this level of hype around humanoids? There's a lot of money that trickles in. And to give you an idea, the funding for humanoids grew by 300% over the last 2 years. And $40.9 billion was invested into humanoids. So again, really exciting because the industry folks have a lot of thoughts about humanoids. There are probably not so many reasons for a robot to have leg and all this technological capability, but the argument for humanoids is that the world was built for humans. So I think a robot in our form just makes a lot of sense. So I mean, there are many different ways to segment a robot. And if we were having a philosophical conversation about, do we even need robots? And one of the questions that I get asked from folks out of the industry is like, are robots going to take my job? So what I did is I basically broke it down into 3 key use cases. Obviously, there are many different types of robots, but one of the use cases, which I believe are more mission critical, are the use cases where it's dangerous to send a human being. So take a snake robot that is inspecting a sewer line, or a firefighting robot that's working alongside other firefighters, or a robot in combat, or a bomb disposal robot, or in Japan for the Fukushima nuclear disaster. There were all these like robots that were developed to clean up all the mess. So those are the type of use cases which no one's really arguing whether we should have robots or not. And even though they're a smaller section of the number of robots deployed, the value added is really high. There are also a lot of robots in healthcare. There are surgical robots that do minimally invasive surgeries. So again, there are some feel-good use cases here. Now, the second, and I would say the biggest use case for robots is industrial robots. These are the big four, the FANUC, ABB, KUKA, Yaskawa. They dominate the space, and there's an entire ecosystem built around these 4 companies. So these are your traditional 6-axis arms for welding, painting, assembly, and used a lot in automotive industry. So I have a video of Tesla using some of these robots to just give you an idea of the scale. So quite fascinating. There's also a gigafactory video that doesn't show humans and it's very futuristic, but I decided to show that there are humans working in the factory as well. And then on the other end, you have collaborative robots. So these are typically, they have lower payloads, they work alongside humans, and there's no safety cell that is needed. And I have been consulting with a food and beverage client. So I wanted to share a video of their use case. While this is exactly the robot partner that we have been working with, the use case is they're a candy manufacturing company and they process corn syrup totes. So over an 8-hour shift, you have a human being that works with a machine that dispenses a 3,000 pound of corn syrup into 18-pound buckets. So what they do is they make this kind of Betty Crocker mix, which is exactly measured and sent over to cloud kitchens to make candy. So over an 8-hour shift, you have a person carrying an 18-pound bucket, placing it on the pallet, and doing this repeatedly, of course, taking a tiny break in between their 8-hour shift. But that's actually a really good use case for a cobot. And like some of the common use cases are packaging, palletizing, quality inspection. So this is a video that I'd like to share with you. So you have the cobot arm, you have the end effector, you have the controller. So any use case that requires repeated motion or repeating 3 or 4 different tasks is probably a good use case, and also works really well for smaller manufacturers. And then the last use case is service and home robots. So I've been part of the robotics industry for 8 years. This is where I've spent most of my time. These are your food delivery robots. Maybe you've seen one at a college campus. They're indoor or outdoor robots. They're commercial cleaning robots, information kiosks. So I'd like to show you a visual of one such robot. Meet my robot, Temi. And I'm going to turn my camera. Hey, Temi. Go to front window. So I just summoned Temi to come to me. And let me know if you can't see it.
Oh, we can see it. I love
Okay.
it.
Can
Great.
we?
So Temi was actually developed to be a home robot. They raised $100 million to be a sort of Alexa on wheels or a Zoom call on wheels. You can play radio. It's also it's based off Android, so it's also very developer friendly, and you can add whatever apps you want, the radio. Right now, Alexa, it actually has ChatGPT integrated into it. So if I were to ask, hey, Temi, can you tell me a little bit about Asian women advancing AI?
Asian women are making significant strides in the field of artificial intelligence, AI, contributing to its development and advocating for diversity within the industry. Here are some highlights. 1. Leadership and advocacy. Organizations like Asian Women Advancing AI, AWAAI, co-founded by Uvika Sharma and Padmini Soni, aim to support and promote Asian women in the AI sector. They focus on creating opportunities and fostering a community for women in technology.
So that's a great like ChatGPT type use case. I usually take these robots to events and we can program it to give whatever information you want about the event. Artilligent, my company, also has sold these at international airports. So we had about 10 of these deployed at Bangalore International Airport, which has about 18 million passengers, so about the size of like JFK. And you can imagine all the different dialects. It's very much like an international airport and sees people from all around the world. So not only does it help you answer questions, but if you wanted to find out where the nearest coffee shop is, it also takes you there. Now, something that Temi did right after raising money to be a home robot, they actually ended up finding better adoption in businesses. So they worked within healthcare for virtual telehealth visits, museum tours, being an office concierge, and there are about 100,000 of these deployed around the world. They also sell the platform, off-the-shelf platform, which has been an amazing technology for us because we use 3D printing and then add an AI layer on top of that. So we have built robots that look like Coca-Cola. We work with WPP, which is Coke's marketing agency, and I'm going to send it back to its home base. But it's always fun to summon a robot, and hopefully this gives you a little idea of what it'll be once we have humanoids and being able to just call on a humanoid. So yeah, we've built robots for Coca-Cola at a supermarket in Lucknow. We have they had a few new offerings like Sprite Zero, so we did promotion around that and build a robot with 3D printing, and then also Jack Daniels and Coke, which is their alcoholic offering. Outside of that, we've also worked with DHL and Reliance on more kind of serious use cases and prototypes, but the experiential marketing ones are always fun. They're very viral, and we love watching all the videos. So on the other side, you have home robots, and of course, many of you may have a Roomba, iRobot, or some other version of a Roomba. iRobot is the most commercially successful robotics company ever, and they sold 50 million plus units. Despite that, they went bankrupt. So there was an offer by Amazon that didn't go through, and they were finally acquired by the Chinese manufacturing company that actually built these Roombas. So that's to highlight, and again, as we talk about humanoids and this idea of a humanoid in every house, the most commercially successful robot company going bankrupt highlights a few things, but one that I want to touch upon is that at the end of the day, a robot is a combination of actuators, sensors, software. So you really can't patent it in the same way as you can maybe other devices or technology. So what that means is there are always going to be copycat versions of it. And despite the fact that iRobot was such a leader, it didn't exactly have the fate that everyone kind of had thought they would. Outside of Roomba, there's also lawn mowing, pool cleaning robots. Robots for companionship is also something that comes up quite a bit. And I would say service robots is very exciting for us. Commercializing and reselling service robots feels like will be a good sort of experience and a lot of like on the ground intel, especially as we start seeing humanoids in homes. So that brings me to humanoids, and there's been a Cambrian explosion of the humanoids that we're seeing on the market, especially in the last 5 or 6 years. And I'll talk about why that has been in a minute. But some of the players that you see are, of course, Tesla's Optimus. You have Figure, which is and backed by NVIDIA. They have full body autonomy. They're currently deployed at BMW in South Carolina. You have Boston Dynamics that we spoke about. They have a Hyundai partnership. You have Unitree, a robot that recently IPO'd in China that starts at $16,000. And NVIDIA announced a partnership with their platform. You have 1X Neo that is gunning for the at-the-home robot butler type of a use case. And then you have Agility Robotics, which is female-led, and they have a partnership with Toyota. So the race to build an affordable general-purpose humanoid robot is definitely accelerating. Morgan Stanley estimates that by 2050, that number is going to reach $5 trillion, which means there'll be a billion humanoids amongst us. Now, folks at the industry heavily criticize this notion. And there's a lot of conversation about, do we really even need humanoids? Like, if, for example, Temi has wheels, like, does Temi need legs? And you can argue that there are a lot of like unstructured environments. And going back to what I said earlier, that the world is built for humans. If there's a nuclear disaster, absolutely makes sense to send a humanoid. But maybe in the home use case, may not make sense. But there is a lot of excitement. And I feel that Elon Musk has definitely set this vision of humanoid being the price of a car. So what exactly is the reason we're seeing a surge in so many humanoids, especially in the last 6 years or so? There's been a lot of hardware improvement that has happened over the last 10 years. So you have actuators and motors that have become cheaper. Earlier, all the actuators and motors, especially in a robot like Atlas, was hydraulic, and that's how it could do those really fun viral backflips. But over a period of time, it moved to electric, which does make it cheaper. However, there's a report that I read recently that 60% of the total humanoid cost is still actuators and motors. And that does give China a huge edge over us because they sort of own the entire robotic supply chain. Sensors and vision have gotten cheaper as well. So when I joined the industry in 2018, I used to be the head of sales for a Silicon Valley robotics company where we also 3D printed robots, and a LiDAR was over $1,000. Today, a LiDAR costs under $100, so makes it much easier to build a robot. You also have extended battery times. I saw this phenomenal demo of Atlas. At the end of its, when the battery is low, it replaces its own battery. It takes about 3 minutes to do so. So now you can have an Atlas robot work for 24 hours a day with that tiny 3-minute break. It probably doesn't need to take any bathroom breaks or lunch breaks like humans. So I think the battery and I think a lot of this is, of course, built upon EV technology and battery. And then you also had ROS2, which is Robot Operating System, sort of emerge as a universal middleware. You started seeing a lot of like off-the-shelf bases. And why this is, or platforms, and why this is helpful is, in the past, you would need to build a chassis, you would need to build sensors, you would need to build an entire robot. But now you could start kind of doing this plug and play and creating prototypes. And then, of course, 3D printing enabled a lot of startups like Artilligent. You also have edge compute, which is AI inference at low power, which, if a robot has a lot of like complex tasks, it's able to do that without being able to refer to the cloud. And all of these kind of improvements meant that the physical layer of the robot of the platform became commoditized. So hardware got commoditized, and it's very similar to your television flat screen TV costing $2,000, and now you can buy one for under $200. There's also a lot of like copycat versions of robot that started popping out of China, and honestly, I remember even like back until like 2020. They didn't really have a lot of credibility. It was looked down as like a Chinese robot. Today, China competes very much at the same level. And there are a lot of like amazing companies that have set up channel partnerships and distributorships in the US and have raised billions of dollars. So again, a very exciting time. And if you go to a robotics conference, it's very likely that people are talking about the race between US and China. And there's also a National Security Commission for Robotics. It's a bipartisan bill that was announced earlier today to make sure that US remains competitive in this area. So that does bring me to AI. And once the hardware layer is commoditized, the next set of problems that the industry started working on is, how do you test a robot? So even if a robot is cheap, let's say a humanoid costs $100,000, testing it in the real world can be very expensive and unsafe. So you now have platforms like NVIDIA's Isaac Sim or Google's Mujoko, where you can create a model of your robot in a photorealistic simulated environment, which is enabled by physics. So you can program gravity, force, torque. You can test different motors on your robots. And you can use reinforcement learning agents that can do millions of trials simultaneously, which makes it very safe and cheap for you to train these robots. So we'll watch a video of Isaac Sim in a minute. But what I do want to add is, despite the fact that this vision exists, that we can now train all these robots in simulation and send them out in the real world, the truth is the real world is really messy. There are always going to be these edge cases or variances. So Isaac or Cosmos, which is also another platform by NVIDIA, allows you to add that variance. So I'll give you an example of a demo that I saw for a self-driving car. If you have synthetic data for, or if you have real-world data of, or a video of a self-driving car driving, you can add variants like weather. You can add variants for a robot arm, whether it's on a metal table or a wood table. You can also add an edge case of a bear walking across the self-driving vehicle. So again, it's really exciting that you're able to do all of this in simulation. And the goal here is to kind of create a feedback loop where it's sim to real, and then you take the real to sim, and you teach the robot these policies that also run on the physical robot. So there's continuous improvement feedback loop until the simulated environment is almost statistically identical to the real world. So here's a video that I want to share with you about the sim to real gap with
Successful
NVIDIA's
development,
Isaac Sim.
training, and testing of complex robots for real-world applications demand high-fidelity simulation and accurate physics. Built on NVIDIA's Omniverse platform, Isaac Sim combines immersive, physically accurate, photorealistic environments with complex virtual robots. Let's look at 3 very different AI-based robots being developed by our partners using Isaac Sim. Fraunhofer IML, a technology leader in logistics, uses NVIDIA Isaac Sim for the virtual development of Obelix, a highly dynamic indoor-outdoor autonomous mobile robot, or AMR. After importing over 5,400 parts from CAD and rigging with Omniverse physics, the virtual robot moves just as deftly in simulation as it does in the real world. This not only accelerates virtual development, but also enables scaling to larger scenarios. Next, Festo, well known for industrial automation, uses Isaac Sim to develop intelligent skills for collaborative robots or cobots requiring acute awareness of their environment, human partners, and tasks. Festo uses Cortex, an Isaac Sim tool that dramatically simplifies programming cobot skills. For perception, AI models used in this task were trained using only synthetic data generated by Isaac Replicator. Finally, there's Animal, a robot dog developed by a leading robotics research group from ETH Zurich and Swiss Mile. Using end-to-end GPU-accelerated reinforcement learning, Animal, whose feet were replaced with wheels, learned to walk over urban terrain within minutes rather than weeks using NVIDIA's Isaac Gym training tool. The locomotion policy was verified in Isaac Sim and deployed on a real Animal. This is a compelling demonstration of simulator training for real-world deployment. From training perception and policies to hardware in-loop, Isaac Sim is the tool to build AI-based robots that are born in simulation to work and play in the real world.
So that brings me to the meat of the conversation, which is large behavioral models. So the hardware layer is commoditized. It's easier than ever before to train robots in a simulated environment. Now, similar to large language models or that generate text or multimodal models that generate images and videos, you have large behavioral models that generate robot actions. So how does it work? Most of these robots work with a VLA model. So that's vision, language, action. And the robot, because it has computer vision, has perception and an understanding of the world around it. It also uses natural language prompts to understand its tasks, and then the model predicts what the robot action should be. So an example of this is Google's DeepMind. So if you look at this image here, so Google DeepMind's RT2 project, there's a robot arm, there's a computer, it has a face and computer vision. And for the first time, it was asked to pick up an extinct animal. So you can see there are multiple objects like stuffed toys. I believe there's a stuffed tiger, there's a football, there's a soccer ball, and there are many different objects. The robot has not been programmed or trained to pick up an extinct animal, but based on the information that it has from Wikipedia, it knows that a dinosaur is an extinct animal and it picks it up. So that's really exciting because that means that the robot has the ability to go out in the real world and act upon things that it has never been trained on before. You also have a diffusion policy. So Toyota Research Institute explains this as being able to train a robot on one action and then create an array of tasks. And the idea of diffusion policy, it's generating a smooth multi-step manipulation trajectory. So a real world example of this would be, let's say Padmini and I were to host a dinner party and invite all of you. And at the end of this dinner, two of you volunteer to clear the dishes off the table, right? Now, depending, and let's say we throw this party every week, and based on our serveware, whether we are drinking wine or cocktails, everything is quite different in the real world, right? However, if two of you volunteered, you would do that task quite differently. There's so many permutation combinations in which you can clear a table. And there are some implicit rules in the real world, right? Like unless you're barbaric, you're probably stacking the larger plates first, and then you're stacking the smaller plates. Or if you're stacking a dishwasher, that is even better defined, right? Like, where the silverware goes. But even for a simple task, let's say, like picking up a wine glass that's half full, the robot has to make sure that it doesn't tilt the glass while picking it up because it could spill. So how do you now train the robot to do all these complicated tasks? So the problem that a lot of players are now trying to solve with foundational models is you have any robot or any task, and it's able to use that model or one brain to be able to do all of these different tasks. So the players that have emerged here are, Toyota Research Institute has done some incredible work. Their president used to be an advisor for the startup that I worked for and now works for Symbotic, which was the startup that acquired Omni Labs, the startup that I worked for formerly. And Google DeepMind is working on cross-embodiment. So this idea that you can train one robot for a particular task, and then the same model can work across many different distinct robots. You also have Figure AI that's working on full body AI for humanoids. And then NVIDIA has their own foundation model. There are startups like Skilled AI, Generalist, Physical Intelligence that are working on this generalist robot policy. And then also Real World, which is a South Korean startup, and they're working with dexterity. So dexterity or degrees of freedom is basically how we move our joints and hands. Our body, I believe, has like 40 or 45 degrees of freedom, all the different ways in which we can move our fingers and hands. And that kind of enables us to pick up a phone or a glass a certain way. And some of these robots, like Atlas, for example, is more capable than a human being, and it has, I believe, like over 50 degrees of freedom. So in some ways, the hardware is becoming more dexterous, and you also have these large behavioral models with vision VLA models that are being trained to basically teach these robots to do tasks, complete tasks. And within each task, it knows what the subtasks are. And once it's out in the real world, it also improves and learns as we go. So I do have a question for all of you. What would you think is like the biggest bottleneck? And it's the answer's very similar. I think I've heard many sessions with Padmini and Uvika kind of talk about this, but maybe someone else can take a stab at it. What would you think is the biggest bottleneck with large behavioral models?
I would say data, like.
Correct. Yeah. So it's data, right? Large language models had internet scale data. There really isn't a lot of like real world data on human movements. I mean, you have videos. You also, with Isaac Sim or Cosmos, have the ability of taking videos and training or creating synthetic, doing domain randomization and creating synthetic data. And if you remember a lot of like humanoid robots from maybe like a year or 2 years ago, it seems they're being teleoperated. I think Tesla's Optimus also probably had a paid actor dress up in a suit and walk on the stage at some point. But with most of these robots, and I think like Neo, for example, which is 1X Technologies humanoid, is able to do a lot of like those robot butler at home tasks. But if it doesn't know how to do a task, it basically sends a signal to somebody sitting in an office, and that person's able to take over and teleoperate the robot. But the point of teleoperation or using any sort of like haptics or VR headset and like humans training these humanoids is data. There really isn't like internet scale data available. So as a result, we're seeing a sort of data supply chain emerge, and gig workers of today are training tomorrow's robots. So we're seeing players like Micro One, Sunain from LA, Sunday Robotics, even a startup in India that is giving people like headbands, and they're literally kind of their phones are suspended in the air, and they are recording themselves and their hand movements, doing these various chores. And that data is actually being sold to the data buyers, which are these companies on the right. And right now, robotic companies are spending $100 million per year doing this. There are many opportunities that are going to emerge within this because it's a lot of like unstructured data that needs to be cleaned up. Like obviously not all videos are usable. How do you label that? So again, quite exciting, just at the speed of which all of like an entire ecosystem, these new companies that have emerged, and the kind of capital that is available to a lot of these companies as well. So here's a video from Generalist, and that sort of gives you an idea of how you can take one brain and use it across many robots. And then we can talk about robotics ChatGPT moment and whether we truly are there or not.
We're developing generalist intelligence from the physical world, and today we're introducing our most advanced model, Gen 1.
It's a brain for many robots. It really understands the physical world and how to act in it. It's trained from scratch on our data set of 500,000 hours of physical experience, and we believe it's the first model to master a broad range of physical skills. It can enable robots to do servicing of other robots. It can fold laundry. It can do industrial kitting of automotive parts. But the point isn't that it can do any one of those tasks. The point is that for the first time in robot learning, we can start to do many of these tasks and do them very well and learn how to do them in a very short amount of time.
So It's really quite exciting. And to answer the question whether robotics is having its ChatGPT moment, I would say it's more like GPT-1. There are still a lot of challenges around data. There's also a lot of challenges around like the real world examples that I gave you earlier. And in many ways, these startups believe that folding laundry is actually the Turing test for physical AGI, because there are so many different variations of fabric and texture and size, right? Like folding a maxi dress is very different than folding a t-shirt. And in many cases, they noticed that if a t-shirt was laid flat, it was much easier for the robot to fold it. But in the real world, if we wanted someone to take a pile of our, dried clothes and fold them, we're not like laying them flat, right? So there are all these challenges that still exist. So hopefully I'm able to ground that into reality. But if we were to wrap it all up, if we were looking at it from the lens of someone who is trying to build a robotics company today versus the 2000s. So in the 2000s was all about the hardware era. You needed $5 to $50 million to start. You would need to build everything from scratch. And then cut to 2020s, we have foundational models, we have off-the-shelf platforms. You can now buy cobots for under $25,000. Humanoids are targeting 16 to 30, and you can actually buy a humanoid from China for that price as well. And the barrier to entry today is much lower. So you have foundation models, you can buy demonstration data from all the players we talked about, and then you can fine tune a VLA model for your specific use case, which is really exciting because what that means is if you have a problem, if you have a business, if you know a business, or if there are workflows that you know better than anyone else, you can really go out there and build a robot today. So, on the top, you have the application layer, then the AI and software layer, the data layer, and the hardware layer. And just like smartphones commoditized hardware and then apps became the value layer, robotics is following the same pattern. And AI or AGI is now going to become the big differentiator. So we as a company have always practiced this. We are obviously very excited about all the partnerships that we have. We're going to make some official announcement very soon. And as I speak to this audience, I would say, especially talking to women, I think a lot of this vision around like robots in hospitals, in homes, in hotels or restaurants, these spaces are dominated by women. And I think it's very important for us to have our perspective. Of course, it is a very male-dominated industry, and there are some women doing incredible work. But there are a lot of opportunities, especially if you're a builder, that are emerging if we were to believe that $5 trillion number. So thank you so much for your time today. I hope this was helpful and fun. Yeah, opening it up for questions.
Evan, the
Yeah.
first one.
Oh
Go
no,
ahead.
this was very, very exciting because I never considered robotics as, I was always taught to look at LLMs and do everything possible with that. But you've opened up a whole new world where I would rather pursue LBMs and robotics and things like that and write a book like Matthew did. But but you said that the robots don't have enough data. We have a lack of data. And yet here we have robot helping a doctor with surgery. So, and the doctor doesn't look concerned. They're letting the robot do it. And they're saying, oh, I'll just jump in if the robot does something wrong. But if we go according to what you said, that robot had to be trained on a million surgeries. Otherwise, why would they let you do it, even with human oversight? So are they trying to set the example and say we prove that this can be done with human oversight? Because without human oversight, then yes, go train the robot on a million surgeries. So I'm concerned that some people are going to be, should they feel safe? even if a robot was trained on 5,000 surgeries, as long as the human doctor is sitting there.
So I mean, and I think that's kind of my Achilles heel. So thank you for asking me a question about surgical robots. But I used to sell medical devices or medical software back in the day, and I did meet a lot of people that sold these surgical robots. They were typically teleoperated, and they're really precise. I would have to really get back to you on how exactly it works, but to answer your question, absolutely, there is absolute human oversight, which will be the case even with humanoids for a very long time. I mean, similar to all right, looks like Matt's leaving. Um, so similar to Waymo, right? Like there are folks sitting in Philippines that can override Waymo. So it's sort of the same concept. But that's a great question. I mean, I'll definitely look into it and get back to you.
Okay, thank you.
Yeah. Anyone else?
Yeah, we have Zeba next and then Tripat.
Hi, thank you so much for the session. I've heard you speak actually at DC Startup and Tech Week in 2024 as well. I was there. And I don't think we met in person, but I've seen you speak and I've heard you speak with the robot as well. I think this was a great session. I don't know much about robotics in general because I'm a software engineer. So I have a couple of questions so I'm currently following what Fei Li is doing with world models. And I'm curious, is that something you see happening? Is that something of use in the robotics field? Like, because the way she's thinking of like the large language models have a limitation, and the way ahead is to think of like how we perceive world. And that's something very interesting. And I was wondering if that's something you see in robotics field. Uh, my second question is, I went to India recently and I was like, I was home after 2 years and I was seeing that the crowd is like so not very AI focused as much as I see in like US. Like I hear people talk about like AI everywhere. Unlike in India, like people are still living very normal lives. And in a country like India where it's so highly populated and you've worked with like so many AI use cases, like with Hyderabad supermarket or like Bangalore airport, how have you seen people adopting and reacting to like these robots in like a very high populated state? Like what sort of issues have you seen and what sort of feedback have you received with like robots in such a place?
Yeah, those are really good questions. So, to answer the first one, there is also this kind of school of thought where you can take world models and the hardware almost doesn't really matter. You can basically just take those world models and then, you know, you
Hmm.
don't really need to train a robot on a task, is the idea. I'm not entirely sure how all of that will come together, but I know like NVIDIA is working a lot with like world models. Now, talking about India. So India is of course it's been the IT hub of the world for a very long time, and I think that's really our strength. Even with Artelligent, we would build, and Temi is of course a really big company. We have been their most innovative partner because we had all these like system integrations that we were doing, adding the software layers, and we have an entire library of like industrial or working with Fortune 100 companies and like building on those use cases. Where I see India with the type of robots that we have been able to sell is there's a huge kind of make in India movement, and there's a lot of like excitement around building custom robots. Now, I kind of don't agree with your assessment that folks in India are not really talking about AI. It really depends, right? Like for someone who's in the tech space in Bangalore may have a very, very different perception of it. Padmini and Uvika went to the India AI Summit. They probably only met people that were working on AI. I have been attending a lot of like a section which is like a consulting company, their sessions, and I see a lot of like speakers from India talk about enterprise adoption. Like I think there was someone from Tech Mahindra that I listened to recently. I would say they're probably not worried about disruption and layoffs in a way that maybe we are, because maybe they're getting the jobs. I don't know. But I would say I'm not entirely sure about that sentiment. I think if you are in the right circles, you're definitely talking about how the world is being disrupted. But to go back to the race for humanoids, one figure that I forgot to share is China, as a country, has set aside $295 billion to focus on humanoids and the supply chain around it, which means that the US will have a very hard time competing with that, especially on the hardware side. Europe is nowhere in that race. I mean, even though, like there are a lot of robots coming from Germany or Switzerland, and we are obviously, given the capital that we have and the funding that we can raise, we're really gunning to be the brain of the robot. So it's very likely it's between China and India. The other challenge that India has is we really need low-cost robots. 130,000, like Spot, for example, the quadruped costs $130,000. There's just no way someone in India is using that, right? So as hardware becomes cheaper, there are also like incredible startups that are coming out of, I think there's AdWorb, there's another startup that I completely forgot. Autonomy, which is a food delivery robot company. They manufacture their robots in Noida. So there is an ecosystem that's emerging, but there's a lot of price sensitivity in a country like India as well. Sorry for the long-winded answer.
No, I love it. I think, yeah, I agree with you. I think the conversation is very like tech focused. Like my dad is a doctor. He has no idea what ChatGPT is. He asked me and I'm like, it's okay. So I
I
think it's
think I
like,
read, and maybe Uvika and Padmini, you can correct me. I think it's like 16% of the like population of the world actually uses AI,
yeah.
right?
Yeah, that was a thing that was doing the rounds on LinkedIn where they had that little,
Right.
the
Yeah,
grid of, and 84% of the world is not
Yeah.
using. Yeah. So,
correct.
I
Yeah.
know a lot of people who have not touched it. So don't
Mhm.
worry, Zeba. Tell your dad it's okay.
He asked me
He's not
what
behind.
LinkedIn is as well. And I'm like, you're living a good
LinkedIn is
life.
like an
Don't
AI
worry about
bubble.
LinkedIn.
You are on LinkedIn, you're basically in an AI, and tech bubble. So,
Yeah.
no, that was great. I want to be
Yeah.
mindful of time. So I
Yeah.
see Triput's hand is up and then Ashwin next.
Thanks,
Go ahead,
Uvika.
Triput.
Yeah.
Yeah.
Thanks, Ujjwala. It was such an informative session. I totally resonate with what Zeba and Ivan said. Like, even I didn't know much about robotics, but like, I'm learning so much out of this session today. So I also had like a couple of questions. I'll just group them together. So, firstly, so my question was, do you think robotics, humanoid can be integrated to our day-to-day lives, just how ChatGPT is now? Like currently we have Tesla and Figure having humanoid being utilized internally in their warehouses and industry, but how do you see it coming to, integrated with our day-to-day life? Because when that happens, the question will arise on the security and the privacy, just how it is on ChatGPT, currently. And on top of that, I had the question. So, like, once it is integrated and we're talking about security, do you think like the usage of local LLMs would become more popular when there's more cases on the data going out to external servers? So do you think like the local LLMs usage would get more popular at that point?
Yeah, so to answer your first question, I'll be very honest. I'm a little skeptical about this idea that there's going to be a billion robots like in our homes by 2050. Um, I mean, if you look at Elon Musk talking about robo taxis, right? Like he said there are going to be 500, there are like 59 out there. So there is a little bit of a hype in all of this. The way I see it is once the technology exists and these robots are ready for the world, there are all these like security concerns that are definitely going to come up. We're going to see a lot of like affluent families probably have robots as sort of the first set of robots. And again, I think one thing I will say is that US has a huge appetite for early adoption of any sort of technology. So there's definitely going to be excitement around that. But at the end of the day, if you look at each of these humanoids, there's a reason they're partnered with automotive companies, right? It's that assembly line, it's that business problem, it's that proximity to a pain point in a use case that really matters more, right? Even if, let's say, magic wand, a robot, a humanoid existed in the world that for $20,000 or $30,000, how many of you would really pay $30,000 for a humanoid, right? Like if oh, you would? You guys like, great. Well, so I think there are so many business models that are going to come out of it. What is the warranty on these? How often do we have to buy it? So I think as far as, and the truth is that US has not been in the top 3 or 4 countries when it comes to robotics adoption, right? Like we don't adopt robots in the same way that China or South Korea or Japan do, because they do really have an aging population. They do really have a labor shortage. The other challenge that we have is we are a heavily services oriented country. And that means that that human aspect really matters, right? Like even with food delivery robots, people want to go to a restaurant because they want to chat up with a server. And so I'm a little skeptical. I mean, of course, we'll see and I think I gave Temi as an example, which they went out and raised $100 million to be a home robot, but they currently have over 100,000 robots deployed, and most of them are in business applications. So once the pressure, I mean, right now the valuations are just crazy across the board, I would say. But once when rubber hits the road and, the investors come and talk about ROI, it's quite possible that everyone's going to focus on business applications. And as a business owner, really want to be focused on those problems, right? Like I want to be close to businesses and identify what the challenges are there. What was your second question? Sorry.
It was about would the popularity of local LLMs increase if we have humanoids, integrated in our day-to-day life? If everyone has, or like most people have humanoid, would the usage of local LLMs increase?
I would think so. I would say that it probably depends on the use case, right?
Mm-hmm.
So maybe healthcare could be a good use case for that. But yeah, maybe.
Okay.
Yeah. All right, Ashwin.
I'll take us home. First of all, thank you for the presentation. It was really, really educational, really wonderful, nicely done. I wanted to offer a comment for Zeba's question. I think China, for example, right, is another big country, and there is no fear. I don't think they are as afraid of any other sort of demographics in general. Either it's good regulations or maybe some control, some power controlling how it is used, and the generalization or the commoditization of the use cases. So that's another example to parallelly compare to India. But my question is, this is very timely. I was watching CBS 60 Minutes yesterday. I think it was Boston Robotics. They are saying we are so close because now there is a clash between AI and robotics that that is so opportunistic that you give the robot a problem, and maybe the example you gave earlier, right, clearing a table, it may find a sixth, eighth, 10th way of doing it more efficiently. That is a real scary situation. I think you just tell it something and it figures out what to do and the best way to do it.
Yeah.
I wanted your opinion on how far are we from achieving that status, right? Just tell it to figure it out and it figures out what it does. And the second question, robot for me is synonymous with warehouses or heavy duty applications. Have you talked to anyone? Are you considering examples or use cases for softer skilled scenarios like education, financial services, office jobs, those kinds of things where robots are being thought of as examples? Just wanted your opinion there.
Yeah. So I'll answer your second question first. So a lot of service robots really focused on like financial institutions, and we've looked at like all the services that can be sort of augmented with robots. However, up until this point, I feel like the technology like really didn't exist. I would say that the softest use case for me is companionship, right? Like especially with elder care, I think that's a use case that we're going to definitely see emerge a lot. There are a lot of robots that have come and gone, unfortunately, and I am not entirely sure if it has something to do with adoption. The adoption challenge, and again, goes to the AI conversation as well. And I think a lot of what Padmini and Uvika talk about, right? Like that change management when robots really become like, is it going to be an overkill, right? Like it's going to be exciting in the beginning to have robots for all these different use cases. But then, everyone's going to crave maybe just having, if you go to a bank, you want to go talk to a person, maybe,
Right.
as an example. The other argument that comes up quite a bit is maybe there's a washing machine or, like your Instant Pot or like an appliance that can become smarter, right? Like we don't maybe need like robots. So there's a lot of like things that are happening on the other end too, right? Like how is a humanoid different than a kiosk where you can maybe have a natural language conversation, right? Like through a drive-through being able to like order. So there are those type of questions that come up too. But right now, I would say, coming to your question about the robot being able to do tasks more efficiently.
My first name is Ramesh, last name is Viju.
Maybe we.
Sorry.
And were you calling in for yourself or someone else?
Or my son.
Yeah, I think he's accidentally
whoever
on.
designed this,
Yeah.
let me just mute this person.
Okay. Yeah. All right.
Thank you.
Yeah, as far as robots doing things more efficiently, I believe that's absolutely going to happen. And I worry about how that's like, what does that even mean, right? Like to be a human being anymore. I mean, I would definitely feel daunted. And we notice this a lot as we sell like even food delivery robots, right? Like the servers are very, very intimidated, especially at the demo stage where they're like, oh, this is clearly going to take my job away. But as they get more comfortable with it, and that is something, again, on the business side is like all about change management and like, how do you define it? How people perceive that. And in many cases, the truth is that you can really move humans to a more maybe pay them more and have them do more like valuable tasks instead of focusing on, the basic repeatable, going back to the bucket example that I gave, right? Like that's probably not the best use case for a human being. But yeah, we're going to see a lot of craziness as well. And those are going to go viral, like similar to your self-driving cars, right? Like every crash is front page news. So we're going to see a lot of that. But I have immense respect for Boston Dynamics and Atlas. They've, if you look at all the humanoids around the globe, they've benefited so much from all the research that they have done.
100%.
And yeah, it almost feels sad sometimes from an industry perspective to see Tesla's Optimus be pitted against something like Boston Dynamics. But they're focused on that specialized use case. They're working with Hyundai. They're working with the automotive industry. They don't even claim to be a humanoid. They claim to be more like human-like and built for, the world of humans. So yeah, it's all very interesting. Again, as a business, I think, or if you are looking to build, I would say stay focused on the business use cases, find a problem to solve. And I think it's the same thing with AI too, right? Like if everybody can vibe code the next Salesforce or next Airbnb within 4 hours, what is our moat, right? And the moat is really identifying those business challenges to solve and focus on distribution, focus on building a good company. So yeah, I'd love to stay in touch with all of you. Please connect with me on LinkedIn and hope to keep this dialogue going.
And Ashwin, really quick, thank you so much, Ujjwala.
Yeah,
I've dropped a LinkedIn chat for, some of these software use cases, like this is LEQ, which is for seniors. And one comment, I know we're well over time, Ujjwala, really quick. I think, like you were saying, the human interaction, we as who are seeing this advent of robots and AI and all that in our lifetime, but I feel when we go 2 generations later, it'll just become like how
Normal.
kids nowadays, yeah, normalize, like how kids nowadays expect cell phones to be there. I think there'll be a time where it'll be like, seriously, there was a life without robots, kind of, you know. So in the distant future, if this works out. So
Yeah, I have lots of questions around risk management with robots, so but that could be a
100%,
conversation
yeah.
for another
Yeah.
day. Ujjwala, we want to be
Thank you
very,
so
very
much.
Can I
respectful
ask
of
you
your
guys,
time.
did you guys hear about the Southwest airline? They had a 3.5 foot humanoid called Stewie. He walked through the airport, bought a ticket, walked on the airplane, sat on the window seat, took selfies with passengers, and didn't bother. You know, he was totally normal, and the airline banned all humanoids for life from Southwest. So isn't I think it was totally harmless, and I would if I sat next to Stewie, I would have interacted with him and taken selfies. I would not be scared of him. I don't know why the airline banned.
I think it's a precedent, Evan. It
Yeah.
sets a precedent. So
I love Zebas. We needed a vacation.
I love that. But I mean, yeah, that's a whole separate conversation. I think Servi is a robot, a food delivery robot that's in Chicago, and there have been a lot of like challenges with the city. I think similar food delivery robots have been banned from certain cities because
Yeah.
people don't like sharing sidewalks with robots. So they're coming.
Uber,
There's going to
right?
be a lot of like
Uber has these robots as well. I see them standing in front of like, restaurants. These little, they look like these boxes.
yeah.
like Berkeley as a robot running all over. I was walking there and this like
Yeah.
this little, and this was a few years back. But this has been an amazing session, Ujjwala. My God, you blown our minds
My
with
God, yeah, the
all
mind
that
is
you did.
expanded. I need to go
Yeah.
back and look at the recording. This was just
Thank you.
phenomenal.
Yeah, thank you
Thank
so
you.
Well,
much
I'm
for your
glad.
time, and thank you
Yeah.
everyone for being here today and for staying the extra time.
Yes.
And
Thank you
we'll
so much,
have the
everyone.
recording. And Ujjwala, thank you
Thank
very
you once
much. And
again. And
Thank you
stay
so
tuned for
much.
our next session, guys. It's on June 30th, right?
yeah, it's on
Yes,
June
confirmed.
30th.
Yes, yes. Well, thank you, everyone. Hope you have a wonderful evening. And Ujjwala, you are amazing. Thank
All
And
right.
you.
really
Good night,
quick,
everyone.
put your emails into the into that doc where we can send you reminders of
Yes, we
sessions
are
that are
now
coming up.
tracking all the emails. So in case you don't see the LinkedIn algorithms doing
I
their
know.
work, every time you see a post, we have an Excel sheet where automatically we want you to sign up. So you will get the invite for all our
Notification.
future sessions.
All right.
Great.
I'm
Thank you
blocking
all.
mine.
Bye.
Bye.
Thank
Thank you.
you.
Thank
Thank you,
you.
everyone.
you.
Bye.
Bye.
Bye. Bye.
Bye.